So what you do is demand is going to surge, you increase the spends during that period, and then you get a great outcome in terms of revenue surge, or you get a spike in suppose contribution margin, and then there is a celebration. Hey, we actually spent a lot, but we also got this much lift in performance, so there was an incremental lift. But the problem is there is actually a selection bias which you have not considered during this entire thing. An MMM might take longer to build because you're trying to collect data from various sources. That's what tells you the bigger picture. Like, you might be thinking all this while that Google is driving sales more, but an MMM is going to tell you through something called a saturation curve that where actually it tapers off, where the diminishing returns start setting in, right? You're not just changing a button on a website. You're probably tweaking your bid strategy in Google. You're probably running 5 new creatives on Meta. How do you know which one actually contributed to that change? You have to isolate the effect. And these questions, vague as they may seem right now, this is trying to tell you what is causing the outcome. Okay, and this is a particular kind of framework, this is a particular kind of thinking which actually needs to be brought about and can be really helpful in your day-to-day decision making. So let's dive deeper into this. I'll start with this little mimetic journey, about this thought process. So this is what, this will actually give you what I'm trying to talk about when I'm saying about, when I'm talking about causal inference. So this person is saying, like, I used to think correlation implied causation. The other person is, and then that person goes on to say, then I took a course in statistics. Now I don't. So the other person is saying, like, okay, sounds like the class helped. But the response you might think is, you might think that it would be, yes, the class helped to sort of improve my understanding that correlation implied causation. But the answer instead is, well, maybe. So that maybe is the most important word here. Why is that person saying maybe instead of saying with 100% certainty? There's actually an uncertainty in decision-making processes. That uncertainty is what causal inference deals with. So you're trying to break down customer journeys, you're trying to break down how different channels perform. In all of this analysis, there's uncertainty, and dealing with that uncertainty is the job of statistics, is the job of mathematics, is the job of algorithms. That is what causal inference is going to try and do. So correlation isn't causation is one of the most important things to understand. So suppose in your dashboard or in your spreadsheet that you're using on a day-to-day basis, you have some data from different channels, cost-wise data, clicks-wise data, impressions data, and then you also have store-level revenue, purchase, NCAC, all data is there. And you're just looking at these columns, and I've seen performance marketers actually do that on a practice, and I have been performance marketer as well, and I still have one foot on the performance marketing board precisely to sort of keep, always stay abreast of what's going on there. And I've seen that, okay, so revenue has dropped, contribution margin for the last couple of days has dropped. We have been overspending on Google Ads. Let's reduce the drop. Let's reduce the spend there. This is correlation-based thinking, but that is kind of going into the zone of causation, because you're trying to link directly that, okay, because there was overspending in a certain channel, probably that's why contribution margin dropped. So this linkage is where a lot of problems start to happen, because you're trying to think that correlation is somehow causation, but it's actually not. There are many other factors. It might appear to you, or you might think that it's impossible to know all the factors. That is absolutely true. There are so many factors. Previous speakers, Deepan was also talking about, there are so many reasons why suppose conversion rate can become low or remain consistently low. But it doesn't mean that we give up on that. There has actually been ways like, some of the things that I'm going to talk about, statistical modeling, these are age-old techniques. For very, very long, very large number of many years, people have actually tried doing that. People have done research on that. And there are methods which might look complicated at first, but we're going to try and unfold some of them and see how you can use them. So in performance marketing, understanding why results happen, which is causation, is more valuable than simply spotting patterns, which is correlation. So correlation is really about spotting patterns. And you can do that through very easy means, like in Excel, you can run a simple command and find out correlation. But two factors can be correlated, but actually still not, one of those may still not have a very important contribution in the actual outcome. So that is a statistical property. We will talk about that later, or maybe separately. But here the point is that causal inference helps us avoid misleading insights caused by bias, hidden variables, and selection effects. So let's actually talk about a few terms. So What is hidden variables? Hidden variables are when you are trying to understand impact. Suppose performance has dropped. So you are thinking that maybe these channels are there. These are the channels you're running ads on. Maybe you have organic as well going on. So you think that, okay, so these are the variables that we have. And, the results must be because of these things. You're short on time. Performance marketers are always busy. But the problem is that there are variables beyond that as well. And that is where modeling is important. So modeling takes into account historical data over longer periods of time, and then you create statistical equations. We call them regression models. So you can take into account more variables, which will be beyond just suppose the media variables. Okay, so that's why there's a difference between also media mix modeling and marketing mix modeling. So what is marketing mix modeling? This is coming out from this concept of hidden variables. That is one of those three indices of the triangle that I was talking about in the morning session. This is what Google calls the golden triangle. So attribution or multi-touch attribution, that is one of these corners. The other two tenets are testing and marketing mix modeling. So you use all these three things together to get a holistic picture that will actually help you take better decisions. Selection effects. I'll just give you a good example of selection effects. This can also be called selection bias, and this is incredibly common in performance marketing. Suppose in Indian context, I do this for a lot of international businesses, spending in suppose north of say 500,000 K or maybe 1 million in some cases. Suppose in Indian context, you have a Diwali or Onam, some major festival. You do expect some spike in sales anyway, right? So what you do is demand is going to surge. You increase the spends during that period, and then you get a great outcome in terms of revenue surge, or you get a spike in suppose contribution margin, and then there is a celebration. Hey, we actually spent a lot, but we also got this much lift in performance. So there was an incremental lift. So that is the perspective, an overarching perspective. But the problem is there is actually a selection bias which you have not considered during this entire thing. You have not considered the fact that there was already a surge in demand during that phase. People would have probably bought anyway. A large section, I'm not saying all of them, definitely ads, the increase in spends in ads would have contributed. But what if you could have actually used those dollars somewhere else, maybe even to a top of the funnel, which could have actually gone on to improve performance down the line, instead of actually putting so much money during that festive season. That is basically selection bias. And it can be proved mathematically. I'm not going to do that now, but using some principles of mathematical equations, you can actually prove this. There is selection bias that is always going on. So what is causal inference really? So we talked about how correlation isn't causation, but let's actually understand the word causal inference. So causal inference, there are several frameworks here. You can look them up, but I'm just going to explain some of the basic tenets of it. Look at this picture. This is talking about something called ladder of causation. So you start with association, then you move on to intervention, and then a counterfactual. Let's go to one by one each of these things. So the association means, what is the association between variables? And this is where actually correlation exists. This is relatively easier, and this is something that all of us are always doing, even intuitively. So that is correlation-based thinking. The next is intervention. That is the intervention. That is the action that you're taking on the basis of whatever analysis you have done at the previous level of association. So that is where you do something. So there's actually a concept in the causation inference sort of mathematics. It's called do calculus. So that's where you are actually taking a step. And after that, it comes the most important part, probably a foundational concept. By the way, causal inference is not so much mainstream. How many of you have heard of this term causality or causal inference? Can I get a few hands? Okay, very few. But in marketing, it's still not so much mainstream. But I can guarantee you in the next 6 months to 1 year, it's going to become, if not mainstream, but it's going to become massively important because Google is talking about it. So marketers will have to start talking about it. And the reason why it's happening, because this is coming from fields. This is used in fields like biostatistics and medical research, where knowing what is causing what is extremely important. In marketing, suppose you make a mistake, like you think that, okay, it's coming from Google, but it was actually Meta delivering more so of the results. A business loses money. But in medical research, you make that mistake, a person loses a life. Right. So you have to be very precise. So of course, there's no such thing as 100% precision, but causal inference comes from that tradition where you are constantly rigorously trying to find the real reasons, the real causal impact of things that you're doing. So counterfactual thinking is actually a philosophical concept, but it can be transformed into a mathematical paradigm as well, which means that if something has been done, and if I want to understand its impact, I have to actually understand it by thinking about what would have happened had it never happened at all. So suppose you were running a Facebook ads in a particular time of the year. So the example that I just gave, that during a festive season, you had a surge in spend, or maybe you started a new channel, or maybe you are, doing some other kind of marketing campaign. What if you hadn't done that? The problem is that we never have that answer. We have always got, this is what is also called the fundamental problem of causal inference. Means that we can either have one of these two things. Either we do it or we don't. Right? So we will never actually know, if we never ran the campaign, what would have truly happened. So you might think then that's an absurd question to even ask, like how are we going to know that? Well, statistics does have an answer. Mathematically, statistically, it is possible to come as near to the real situation, the real alternative as possible as what would have happened had you not even run that campaign in the first place. Knowing that means that you're getting closer to the real incremental lift beyond any other kinds of analysis. Again, this is only going to complement other methods. This is going to complement attribution. So just think of it in, sort of a holistic picture. So that's counterfactual thinking. I'm going to come to that. This might sound a little vague right now, but I'm going to come to real examples and how through different methods this can actually be implemented. So this is the causal inference spectrum in general. It separates correlation from causation by comparing outcomes against a valid counterfactual. So that counterfactual concept is going to be very fundamental to any of the causal inference methods that we're going to talk about in just a minute. So let's quickly have a recap of the history of attribution versus, or maybe if not versus, but attribution and causality. So this first line, this second sentence that you see here, so MMM has actually, so marketing mix modeling, MMM stands for marketing mix modeling. It's not media mix modeling, by the way. A lot of people mistakenly do that, say that, but it's not true, because a regression model, the understanding of what exactly is causing outcomes or impact, that is a combination of different kinds of variables. So everything that falls within the larger 4P spectrum paradigm of marketing, not just media variables. So marketing mix modeling is very old. It's been going on since the middle of 20th century, or maybe even earlier. So because it's rooted in statistical traditions. Then came attribution, which is much, much later, when digital technology actually boomed, when you had the capability of connecting the dots, when you could actually start measuring the customer journey. And this was absolutely making waves. So MMM became sort of sidelined because of the fact that you could start actually measuring customer journey and not just depend on statistical methods. But the problem happened, like people have already been talking about, when during the COVID or during iOS, when those privacy regulations started appearing, there were the gaps then that started appearing. You could not anymore track it properly. Of course, with first-party data, you can supplement that process, but there's still going to be gaps in the tracking system, in the tracking ecosystem. So again, there was a renewed interest in MMM when you wanted to use statistical models. And by the way, it does not have to be exclusive. This is about complementing each other. So I keep repeating that. And it may not necessarily also be MMM. You can also have better attribution models. In the morning, I gave the example of Markov chain models for custom attribution modeling. So you can actually also do better modeling even using the data from tracking. And finally, in the evolution, we have causality. So what exactly is causing? And this is all coming from real business requirements. People now want to know where the next dollar should be spent and how much the return is going to be from. That people have already been talking about. Like profitability is absolutely the end game here. And that is why people are talking about causality. This is being spoken about more in the US and in the European countries right now, but it's not going to be too far when it's going to start being talked about more in India also. So these three, that is the cycle. So you can see that it's a kind of a cycle, because MMM also has a claim towards causality. It tries to tell you that these are all the variables you have. Like theoretically, if you can measure all the variables and you can put them in the proper scientific manner in a regression model in an MMM, you are essentially also creating a causal model in theory. So there is that cycle here. So from MMM to attribution, and then you're back to again MMM and causality. That is what this is representing. So now let's look at quickly some of the individual aspects and attribution. So what is the primary question that attribution is asking? Who gets the conversion? Who gets the credit for a conversion? MMM asks, how much does each channel or variable contribute to sales over time? So it's all about measuring the impact individually of different channels. Again, channel or variable, because there can be other non-media variables. Causal inference goes a step further and asks, did this marketing activity cause incremental lift? So it's actually trying to answer that question of what if. There's literally a book called What If, by the way, if you're interested on this. So level of analysis, user or journey level in attribution, very useful, of course, very granular. MMM is more aggregate level. That is where you take channels, regions, time series, like Vishnu was pointing out in the morning. And then you have causal inference, which actually gives you test versus control. So you are going to do on something, you're going to apply it on a geo, you're going to apply it on a specific set of products maybe, and then not do it on the others, and then compare if they are comparable. Then you also have data requirements, differences, digital user journey data, time series data for MMM, and similar to MMM in case of causal inference, but a shorter time frame. So causal inference methods, by the way, is, they are going to be used for incrementality testing, as we're going to learn shortly. So incrementality testing is usually for a shorter time frame. This is to sort of complement MMM methods. They complement each other. So you can run it within, say, 2 weeks to maybe a month. And MMM might take longer to build because you're trying to collect data from various sources. That's what tells you the bigger picture. Like you might be thinking all this while that Google is driving sales more, but an MMM is going to tell you through something called a saturation curve that where actually it tapers off, where the diminishing returns start setting in. So the unit economics really plays out much more clearly in MMM. So we're going to talk about the methods. So rule-based or heuristic when it comes to attribution. So attribution, the models themselves. So there are two parts in attribution ecosystem. One is the tracking part, which, the first party data ops and all those aspects that we were hearing about brilliantly today. The other part is also the modeling, that what is the method of actually using that to attribute credit to different channels. The usual models which you see in the different channels are like first click, last click, linear, time decay. Some of these have been even deprecated, I believe, in some of the platforms. And then is also, there's this thing which is called black box, data-driven attribution. We actually don't know what is that, to be honest. Have you ever, does anyone really know what is data-driven attribution? Any hands who can explain the math? Okay, I see half of a hand maybe, or maybe 3/4 of a hand, but not many. The reason why, because we don't know how that works. Doesn't mean that we don't know it's bad or the thing is that we don't know, right? So rule-based ones are also called heuristic models. MMM, on the other hand, is econometric modeling. It uses precise statistical principles and methods to actually work on historical data to give you an understanding. Causal inference are more specialized sort of ML models or machine learning models or statistical methods. We're going to see a couple of examples, real-time examples of where I've also implemented and others are also implementing in different businesses. So the strength citing, more or less, we have already talked about, so we can move on to the next one. So now we come to some of the actual methods. So let's talk about the application of causal inference. So there are 3 different ways of looking at causal inference which have a claim to causality, more so than anything else. And this is within the spectrum of statistics, but very much being applied to marketing as well. So we'll classify them into 3 types based on the mechanics of usage. Experimental methods. This is something that a lot of you are already familiar with. RCTs or randomized control trials. This is what A/B testing typically does. So A/B testing on a platform, suppose Google ads or Facebook ads, what it does is it randomly assigns users to either a control group or a test group. This is something, if Google or Facebook does not allow you, you won't be able to do properly. If you're trying to do it through Google ads or Facebook ads, you need the platform to do that for you. But The principle behind it is randomized controlled trials. I cannot explain the whole of it in detail in such a short time, but the idea is that you are randomly assigning users to different groups. The problem with this is that this is very limiting, very difficult to execute in real time, as you understand. Again, if you are using Google or Meta's own systems, then it's another matter. But if you want to do a test of your own, how are you going to do that? How do you know that which user is necessary? Again, this goes back to the problem of actually knowing the user journey precisely. So if you want to avoid that, RCTs actually become more difficult. Then there are geo experiments and holdout tests. These are becoming very, very common. Geo experiments, I think a lot of people are intuitively already doing that. If you want to start a campaign, you want to test a campaign, a new campaign type maybe, or a specific offer, you just do it in a couple of geos. Not, I was just having, hearing a conversation like this, that let's not do it across the entire India. Let's do it only in a few states. That's actually the principle behind it is geo experimentation. But in order to really believe the data to be absolutely correct, you actually need to verify it using statistical methods. So those come under the purview of geo experiments. Holdout tests are very similar, except that you're not doing it only for geos. You can actually have like partial or full holdouts, like you stop Google Ads completely. Now that's a huge thing. Not many people will do that, but some brands do that. I don't know if you're aware, Amazon stopped advertising on Google Ads in pretty much most European countries. How many people knew that? And I think it's still going on, right? Amazon has pulled out from Google Ads. It's a huge thing for, lots of e-commerce businesses. Most people would have thought that CPCs will really drop, right? Because Amazon is such a massive advertiser, right? It's a major competitor for so many brands. It's always right there at the top of the auction insights. But it pulling out from Google Ads means that, it would cause havoc. It didn't. That's a surprising thing. And this was measured. I measured it. A lot of people are starting to measure it through causal impact analysis. Quasi-experimental methods. So I just spoke of the limitations of experimental methods, right? It's very difficult to execute in real time. Assigning users randomly to different groups is hard to do, which is why you have quasi-experimental methods. So these are actually some of the methods. I'll speak about them, a couple of them. So difference in difference, synthetic control method. Don't worry about the names right now. I'm certain that you will start listening, to these names later on. It's still early stage probably talking about these things, but it's going to become much more familiar. Synthetic control method, by the way, is used by one of Meta's own system. I don't know how many people are aware. There's something called GeoLift by Meta. Is anyone aware of that? Can I see a few hands? So GeoLift is actually a specific technology. It's actually something that you have to implement manually. It's a Python package, or it was in fact a R package, which is now also in Python. You have to implement that on your own or through a developer, or whatever means you can. That is using the concept of SCM, or synthetic control method. It's clearly there in the documentation. It's a mathematical process, all of these are, but I'm just exposing you to a few names. I'm not going to read out all the names, doesn't make sense, but each of these have their own pros and cons. Then you have some modeling methods as well. The modeling methods are kind of overlapping with also quasi-experimental, but the difference is that they use more sort of robust MMM-like modeling systems. So causal forest, panel data methods, Bayesian structural time series, and double ML. Bayesian structural time series is by another big company. Can you guess which one? This was by Meta. Any guesses which one might be using Bayesian structural time series? Major platform. Exactly. So Google has actually a package called Causal Impact. It's pretty popular in a lot of industries. Again, probably more outside India right now, but it's going to become popular here. Again, these are open source packages, by the way. And by packages, I mean software packages like, code bases basically. So right now, these are being used by developers. But what AI is going to allow you to do is that you can start using them on your own as well. There's that potential to do that. There are tools that are going to start using that, and you will find yourself probably implementing some of these to carry out experimentation more scientifically. So we have two here, BSTS and SCM, which are used already, by the two top performance marketing platforms. So I'm going to talk about two methods in a little bit more detail. The first one is difference in difference. This is actually a very simple intuition. At the bottom here, you actually see the mathematical equation. There are a lot of terms here, but I'll try to break it down. It's not as complicated as it looks like. All it does is, suppose you start with a control, and test. Okay, so your 1 here is your test, your C is your control. So all you're doing is you're taking two dimensions of differencing, two dimensions of comparison. One is your control and test, and then you have a period as well, like testing period and pre-period. So you're basically taking the difference of test before and after and control before and after. As simple as that. Okay. Now that is what this mathematical equation is already telling you. Y is your outcome. So it can be your sales, your revenue, your causal impact is given by that alpha hat. Don't get, that's what mathematical notations do. They sort of repel people, but that's what I try to do through my YouTube channel or other people. Lots of good content. This is not actually very difficult from an intuition perspective. So all it is trying to tell you is that the difference in outcome between test in the post period and the difference in outcome in the test in the pre-period minus the exact same things for control. So that is this difference in difference. What this is trying to do is mathematically, it is evening out. It is actually eliminating the common factors between these two, which might be causing the outcome. So for instance, if we take the example of that spike in sales during, suppose, a festive season, you are comparing, suppose, two states, right? They are very similar. You have chosen two states. I'm not going into how to choose. That is also actually it's a non-trivial question. But suppose you have chosen two states to compare where you have implemented, in one of the states you have implemented a certain marketing campaign, in another one you have not. Okay, so this becomes your control and test binary. So, but there are going to be other things, right? Again, that's the whole point of causal inference. That's the whole point of counterfactual thinking. What if there are other factors? How do you eliminate the influence of those other factors? That's what differencing and differencing does. Taking a difference between these two levels these two together so that you are only comparing for the effect of the intervention that you're trying to measure. So just to understand, causal impact is always about understanding the effect of one intervention, not everything else that is going on in the world. So that's what you see here. The control group and the treatment group, you see that this is the intervention period. Sorry, it's a little blurry. This three dotted lines here is representing the intervention period, meaning your campaign started here. In the y-axis, you will have in the x-axis, you will have time. So this is before, this is after, and this is your outcome that is being measured in the y-axis. So in the before period, you'll see that these two are following. This is what is called a parallel trend. Okay, so control and treatment has to follow a certain, assumption that they are following a parallel trend. Very similar trend. It might not have to be exactly parallel, but that's why you have to choose control and test as similar sort of elements, entities. Like this can be very similar geographies, and then you measure the difference between these two. That delta that gives you the effect of treatment. So both groups, treatment exposed to ads, control not exposed, are subject to the same external factors. Right? And by looking at the change in each group, we cancel out those common factors. That is what I was trying to say. When we are trying to measure the influence of different kinds of effects, like whatever we are running ads on, whatever new campaigns we are launching, these are always external factors there. We are not taking into account. I'm not saying not everyone is doing that. Maybe a lot of people are doing that, but the most systematic method is this to do. Right? To have some sort of causal methods. So that seasonality, how do you take into account for seasonality? I would love to know actually. Suppose, you are choosing maybe different months in a year, right? So you know that, okay, this much seasonality is there. But seasonality is not necessarily that, okay, during, Onam or during Diwali or maybe something else during Durga Puja, there's a spike. There are other kinds of seasonality also in data. Is anyone actually aware of how you are doing that right now in terms of taking care of seasonality, how you're taking that into account? Yes.
So there is multiple type of seasonalities we see. One is based on the cropping seasons, your Kharif and Rabi. We also see the seasonality patterns based on the weather. Right now, there is a lot of cloudburst happening across India. Right. So that kind of seasonality we do. So what we have done is built a model with weather data along with the cropping data and disease data and see what is the intent of the audience. That's how we measure seasonality today.
Yeah, no, that's a good method. The problem is that you are manually trying to get the data on different kinds of seasonality, right? Yeah. That's the challenge of the data collection process. What this method is trying to do is it's making the process simpler for you. You don't have to, take into account those seasonalities because you're taking this difference. You're basically keeping them at a level so that they are very comparable in the before and in the before period. In the before period, before that actual campaign even happened. Otherwise, they're not comparable. So that differencing allows you to isolate the impact of your campaign that you want to measure the impact of. So that is this whole process. Otherwise, you will have to go through so that entire process of manually gathering the data from different sources, that you will have to go through. That, of course, is a solution. You might want to collect the data on seasonality, apply it, and then actually try to figure out what is that impact, try to isolate that. But without going into that complication, this relatively simpler process is actually going to allow you to measure the impact properly. By the way, this also relies in practice on a regression model. I will actually show how it has been done with an example later on. So that is the first method in focus. The second method in focus is called synthetic controls. I already mentioned this is being used by one of Meta's own packages, GeoLift. It's kind of, I think, like not so much popular yet, even though it's by Meta. By the way, how many people are aware that there is now an attribution method or an attribution sort of strategy now within Meta, which is called incremental attribution? Can I see some hands? There's something called incremental attribution. I'm surprised to see that. Like, I would have expected more hands, but there is actually something called incremental attribution available. I think it's available across most accounts now by now. Not yet. Live everywhere. So it's rolled out. I think it was initially for a few accounts. Now it's getting rolled out everywhere. It's the same team that's behind the creation of Meta's GeoLift, the same Meta's research team. These events, they actually came on YouTube live. They discussed about it. Only people like me who are probably just so interested deeply, they see that. But it is there for you to see. It exists. The methods that they're talking about. So synthetic control, that actually creates. This is a relatively more complicated method than DID, the previous one I just showed, but still not that hard. This output graph that you're seeing, this is from Meta's GeoLift. So what is the average effect on the treated means that what is the average impact on whatever is, the ultimate thing that you're measuring, maybe sales, revenue, contribution margin. So you can see here that there's a graph that's going on, and ultimately, sorry again, it's a bit blurred, but you can see that within that shaded space, there is actually a dotted line here. I don't know if you can see it, but there's a dotted line here, which means that at that point, some implementation was done, some campaign was launched. And then you actually see a clear lift in pattern, right? I mean, from a naive observation also, you can see that there was a certain lift, right? So that is that lift that this model is trying to show you. And this is being done through a statistically robust method. This is the equation for it. Again, a very similar sort of a concept. So you basically have, suppose, n number of n number of units, okay, n number of geos, for instance, and only in one of those are you actually applying whatever you're applying, maybe a new campaign. The rest, you're not doing it. They are all controls. So you are trying to figure out how to actually find out the counterfactual. Remember what I said at the start, that if you had not even run that campaign, what would have been the impact? So in real cases, that if I go back to a previous slide, I talked about one of the experimental methods, which is called holdout test, right? Sorry. So this holdout test means that you actually have to leave out few geographies. So suppose it's a festive season and you want to run a promotional campaign. That's a huge opportunity cost, right, in terms of economics, not running it in some geos. Like you might think that we are not going to, we're going to miss the sales from those. So what if you could actually understand the impact of, not running in some states without actually doing this thing of not running in some states? I know it sounds like a tongue twister, but that's what it's precisely trying to do. Like some geos where you want to hold out. I suppose everyone now understands what is hold out, not doing something somewhere. That's all is hold out, right? You can have a holdout without actually having a holdout. So that you can do by actually creating a synthetic holdout. That is what synthetic controls do. So you actually don't have a control set of geos. Mathematically, using statistical methods, you can come up with a set of controls which are very similar to your test region. These are called synthetic controls. So how does it do it? It does by looking at historical data, but it looks at different kinds of other data that is relevant to the model. And then finally, Sorry, it's going in the other direction. Thanks. This kind of allows you to do this process without actually even potentially losing out money by doing a holdout, right? So that is why it's actually so powerful. It's being built into new age tools which are doing incrementality testing. This is becoming one of the most popular methods. The only drawback is that, so this right hand side of this equation, for those who are a little bit more mathematically inclined, is basically taking certain weights that you assign to each of these different regions. So that finding those weights, these WIs, that is what this is all about. But I'll leave that bit for now. So this actually creates that synthetic twin, which serves as the counterfactual for what would have happened without the treatment. Again, the difference between the treated unit and its synthetic control, right? In a holdout test is the difference between the treated and the real control. So just the difference is between that real control and a mathematically created synthetic control here. That estimates your causal effect. Okay, so how does it tie into first party data? We have been talking about signals getting sent, additional signals which is going to make the tracking, the attribution systems more robust. So it's all a part of the entire ecosystem. And again, sorry again for the presentation not being as good. I can see that now, but this is what is actually a very nice representation of what causal inference is all about. Like, you have variables, you have confounders, you have treatment and outcome, right? So you have these confounders are those additional sort of variables which you are not taking into account when you are trying to understand the impact of certain interventions. You only think about, mostly when performance marketers are doing things on a daily basis, they're trying to think that, okay, my intervention is only those ad channels where I'm sending, where I'm spending money on. But then there are those other factors, like external factors like seasonality, maybe economic factors, how those things actually feature into this entire thing. That, together with first party data, with more signals about the users themselves, that can create a massively rich data ecosystem for you to actually then work on and build better models. So this granularity, so first party data is typically user level. So that's one of the major advantages. Whatever we have been talking about, you'll see that it's not so much user level, because this does not have data from attribution. It is taking data from historically available data, from store level data or channel level data or external data. But together with that, you have the granularity of first party data, which is much more user level data. So that actually creates the opportunity for micro-causal analysis, like which segments truly responded to a new promotion, right? So previously we were talking about sending events, right? Custom events back to Meta, for instance, like which are based on, suppose, product related segments or other kinds of segments. So that is helping you to sort of send better data to Meta and to these algorithms to perform better. Similarly, using the principle of causal inference, this is now going to help you understand not just which channel, but which segment is actually responding better to a promotion, right? So that is, again, the causal inference from a much more granular perspective. Similarly, did frequent or infrequent bias, different kinds of, so there's something called RFM analysis, right? Recency, frequency, and monetization. So that recency, which of those in the recency segmentation, and the buyers, how many of you are aware of RFM analysis? Okay, quite a few. That's reassuring to hear or to see. So people who are more recent purchasers and how recent they are, so that segmentation also from a causal analysis becomes enabled by first party data. So first party data is massive enabler in that spectrum. So what is the tech stack? I've already introduced a few models, right? Few statistical methods. So this is right now pretty technical, but like I say, with AI, what's going to happen is that this is going to become much more accessible, even if you're not technical. And be prepared for it down the line, 6 months from now or somewhere down the line, this will become mainstream. So you will have to deal with it. You will be much more ahead of fellow marketers if you sort of become aware of the background that's going on now. That's already available, rather. So first of all, third-party tools. There are already tools in the market who are starting to use them. I'm sure, CustomerLabs is probably already working on that. So, there are tools like that which you can start using. They obviously will come with a price. So yeah. On the other hand, you have Python and R-based packages and libraries. That also comes with a price. They're open source packages. They're free to use, but then you need developers to implement that. So everything ultimately has a cost. But the point is they're there, available to be used. The next one is open source solutions. These are also open source like the second one, but these are like completed things. Like these are reducing your developmental effort. Like these are low code solutions. I hope that some of you must have heard of no code as opposed to no code. Any hands there? Like no code and no code. Yeah. So these are basically 100% code based solutions, and these are low code solutions. So GeoLift is like maybe 10 15 lines of code in R or Python, and then you actually have your causal impact analysis done. Very similar. I've forgotten now, but I think one or two of these are by companies like Uber as well. So some of the biggest companies which leverage data, I think it is EconML. You can just check that once. EconML is probably developed by Uber, if I'm not wrong. One of these. Match Markets, by the way, is also by Google. It's even older than Causal Impact. So Match Markets does a very similar thing. It matches markets as the name suggests. Like if you're trying to suppose a brand is, like some of the brands I work with, they are running campaigns around the world, different European countries, and sometimes outside Europe as well. So how do you compare? Like suppose you're doing something right now in suppose Netherlands, and you want to know that what's going to be the impact of it in France. So there are differences between Netherlands and France, right? But can you find some geographies within these two which are relatively similar for that comparison to make sense? That can be done mathematically and statistically, as I was speaking. Again, a very similar thing is done by this package. Relatively low code, lesser lines of code. All of this is, again, you don't have to learn coding to implement these. These will be there within the solutions probably that will become available to you very soon. So just being aware of these means that you're already ahead of the game. Similar actually models exist, in some examples. So let's actually come to a couple of case studies. These are live case studies that I have worked on. So this package, I already said, Causal Impact by Google. This is an analysis of CRO intervention. So I was talking about ad waste, but this is a specific change was done in a website, a very small change related to the checkout phase. And again, an international website, but what they really did is to make the CTA button more visible, right? And we were trying to understand, the brand was trying to understand what is exactly the causal impact. Does it make sense to do such analysis, such sort of interventions? Again, why are they trying to even understand? Why was it even necessary? Like CR is being done all the time, right? So why even bother about trying to understand causal impact? That's because you're doing so many other things at the same time, right? You're not just changing a button on a website. You're probably tweaking your bid strategy in Google. You're probably running 5 new creatives on Meta. How do you know which one actually contributed to that change? You have to isolate the effect. And these questions, vague as they may seem right now, are going to become more and more important. I can't stress enough. So the hypothesis was that it will have notable lift in conversions. The good thing is that the marketing team was actually sharp to think that, because I was assisting in this project only from a data point of view, but they actually came forward and they said, we think that this might need some additional analysis. And the bottleneck was, there was a bottleneck in the website journey, which was actually being removed. So it was making the UX and the experience for the user easier, but they wanted to see whether or not it had a noticeable impact. So now let's come to that graph here. So this was, this again, remember the previous graphs. This blue and black, the black represents the original historical data for sales over a period of time. And the blue actually represents what the model predicted. See how the model incredibly, predicts it so well. So this relies, as I said, it is trying to understand the counterfactual, right? That is the whole point of causal inference. I keep going back to that because that's the fundamental. And how does it know the counterfactual? What would have happened if the intervention hadn't, if the CRO change had not happened? By creating a model. See how good the model was. It is almost concurrent with the black line, right? So that's, if you feed the model properly, if you build it properly, and you don't have to do much in this case of causal impact because it's going to use something called Bayesian statistics. It's Bayesian structural time series, as it's called. This is going to do the thing for you. So it's so powerful in predicting how that actual pattern looked like that it's actually able to predict what would have happened had it just carried on normally without this intervention happening. And that is what it measures later on. So it gives you first that impact. You can see that there's a lift beyond this point, right? That is what that CRO impact actually did. Conversions improved by several percentage points after this change. It was so successful that they started implementing it at different layers, and it actually became a very regular practice to keep doing this sort of tests. And we have continued to actually have these kinds of tests frequently after that. And that's again going back to that point, incrementality or causality tests can be done much more frequently than something like MMM, which is a relatively more heavier sort of a thing. Should be done, but probably every once in a few months. This is the statistical output. Several numbers here, but just to give you some idea, the relative effect, if you see I think 1, 2, 3, 4, the fourth row here, that gives you the effect. So you have a significant effect of 0.62% improvement in conversion rate. That is a relative change, which is actually this is for a brand which is making a massive amount of money, like hundreds of millions in terms of revenue every month. And for that to have that kind of improvement in conversion rate is a significant impact. I hope you can measure the impact of that. And this is what is called a 95% confidence interval. Doesn't matter right now if you don't know, but some of you might be aware. This is from statistics. So that is a universal standard of confidence level, like with what is the band of sort of confidence or uncertainty that I'm happy with. So within that 95 confidence interval, you actually had 0.62% lift. So this is an example output from this causal impact analysis, which had a absolutely tangible impact on the business. So there are some terms like posterior probability. These come from the Bayesian statistics that's working in the background. The second one is the example that I was talking about, Amazon's pull out from Google Ads. This will not show. The previous one showed a real impact. This did not show an impact. And the reason why I did that is because there were so many famous LinkedIn influencers who were actually talking about that this is going to create a massive impact. And I was interested because a typical data perspective, wearing the hat, and I believe everyone can wear that hat if I can, because I also come from the same place as many of you who are at least from media buying background. Wearing the hat of a data-oriented person means that you start questioning things, means that you don't take things for granted at face value. This was being claimed that Amazon's pullout is going to create a massive change. Businesses are going to start really having a huge impact because the CPCs are going to become so lower. You're going to have so much, you can bid so cheaply. Nothing happened for majority of businesses. People started talking about it like a few weeks down the line. It's fine to make such predictions, that's also perfectly fine. But you should always have a proper, robust system to actually measure impact. And this actually shows you the parallel trends. Remember what I was saying, this is just the name of the graph, but this is basically the output of the DID, or the difference in difference method. So this is an example graph which it would have looked like. This is the dummy data, which is actually showing you, because the real data did not show such a curve. But if it were, right, if the intervention were there, this is what it would have looked like. The yellow and the blue lines represent CPCs, for the control and the test. And you can see that after the intervention, so basically the concept was like this, that for the blue curve, this is where Amazon did not pull out from, or they were never even present in the first place. They were not even in the auction insights. They were not bidding on the terms in those industries. The blue is where they were present and they did pull out. So if the pullout did actually happen, if the impact was really there because of this pullout, then it would have looked something like this, right? That after that intervention, the ones where they were present and they pulled out from, there would have been a massive dip in CPC. CPC is the place where the most impact would have been predictably, would have supposed to have happened, but it did not. So this is actually a dummy graph. What actually happened is there was no such changes. Because I know there's no point presenting something which, where the graph stays the same, right? So I presented something more dramatic to show you what would have expected, but actually it did not happen in any of the accounts we saw. Like, in fact, reality was like CPC increased during that period, right? Again, if I go back to that first slide when the person was saying, I took a course in statistics, now I, understand that causation is not correlation. If I now ask you the question that instead of this, for some, for most of the accounts, if I give you this feedback that CPC actually increased after Amazon's pullout, and if I ask you Did this happen because of Amazon's pullout? So can we like infer from this that CPCs increased after Amazon's pullout? What would your answers be? Yes or no? Exactly. So you have to question that, and you have to establish that, because that of course goes against your. So I think in this case, maybe the people who would have had the opposite opinion, which is logical, because like a major advertiser, major competitor not bidding anymore means the CPC is going to go down, right? That's what logic dictates. So the immediate, sort of impulsive answer would be, no, that's impossible. CPCs can't increase when Amazon pulls out. Just withhold that reaction. That's what I'm saying. This is beyond the mathematics. This is a mental, sort of an approach. This is a philosophical way also, that, how you actually position your thinking. And the reason why I have, this becomes more important to talk about it is because it's difficult for performance marketers. I know, because I've been in their shoes. I sort of still am. Constantly I see what goes on a daily basis. They have that pressure. They can't think in this. They are not allowed to think in this way. But I would say fight back and start thinking like this. There will be, like your managers or your bosses, they're going to tell you things like that. CPCs are going to plummet. Okay. And you're going to probably, based on that belief, take decisions like that, right? You're going to probably change a bid strategy. So if you think that TROAS, if your CPC is going to decrease, you're probably going to change TROAS. Can anyone tell me what you should be doing? Suppose you expect CPCs to drop. What would you do with the TROAS on Google Ads? Any hands? So, okay. So if CPCs are supposed to drop, when you raise TROAS, what happens? Let me make the question easier. Does CPC increase or decrease when you increase target ROAS on Google Ads? Surely this must be known. CPC will decrease, right? So that's what you are putting pressure on Google to get back better returns, and that typically happens by reducing CPCs, right? You're paying lesser per click. That is why you can expect better returns. But the point is, doing that decision based on such a sort of like an understanding without a data-driven understanding, a sort of an assumption rather, not an understanding, that can be detrimental. So that's what I'm saying, that challenge that thinking. If someone tells you, even if it's a senior or a boss, challenge that thinking and tell that we need to do a causal test before actually, let's wait for a while, let some data gather, and we can do a causal test within a few days. This does not need to be, happening over a couple of weeks or more than a certain period of time. So a lot of terms here like a treatment effect, event, but all of this ultimately, event in statistical causal inference spectrum is mostly that intervention. That's what it means. It's very similar, you can say, to the attribution paradigms event. So what was the summary of assumptions and checks? So just a quick, sort of a reminder that there are the methods, that is why it's a statistically robust method. This might not apply to every case. So there are some assumptions. These are like parallel trends. Like I said, they have to be relatively similar, the control and test, whatever you're comparing. And you should not have any anticipation. This means that placebo tests should be done using fake intervention date, which means that if suppose the intervention happened somewhere before, was there still some change happening? Like that's like a fake intervention. This is like a statistical method. This just shows you that there is actually no real difference before the intervention, which means that the intervention is the one which actually caused the impact. If it's complicated, leave it for now. SADVA is basically an assumption, which means that there are no spillovers. That separate geographies, they basically, they are separated in terms of their influence. They don't influence each other too much. These are mostly very reasonable assumptions, by the way. These are not going to be blockers in a major way. So let's conclude now. So what is the future going to hold for us? And this is what I actually shared. I probably should have shared in the initial slides, but this is what Google actually has mentioned as, the golden triangle. And Meta also has said it. I have forgotten what the name they've given it, but the golden triangle in some of their documents, I would actually request CustomerLabs to also share this initial document, like this PDF, because this is by Google, in case everyone wants to read up on it or at least know what's going on. So they are saying that MTA. So MTA is something that you're all familiar with already, like multi-touch attribution. You're right in the middle of attribution, but they are saying that you need to complement it with other things. Again, this is probably not for very newbie brands, like spending, say, like a few lakhs a month. INR, probably, or at least like, so probably not so much for them. So it's very difficult to say exactly at what point this becomes, that there's no clear line like that, there's X amount of money in terms of spends or X amount of revenue. But probably for very new brands, it's not so much relevant, but it's going to become relevant. Probably safe to say that as you keep on increasing spends, as you grow as a business. So you need to complement MTA with experiments and MMM. So your MMM is your model-based thing, and your experiments is basically your, the incrementality test that I was talking about. And together, these can actually give you how actually there's a method called triangulation, how to bring these three things together. There is absolutely no unanimity, whether in the academic world or in industry, how the triangulation has to be done. So that is still sort of, we are actually making history as we speak as well. How to actually bring about that, maybe one of you will come up with the most, universally adopted solution. So this is a thought process. Anyone has any ideas how to bring these three things together? Any rough ideas, any off the top of the head ideas based on whatever we have discussed so far? Okay. So more than just a buzz, must use it responsibly to unearth meaningful insights. The idea is again not to do away with attribution, but to complement it, to fill in the gaps. Pretty much, I think I've covered all the things here. Any questions? Anything about the case studies or anything about how you can start implementing it in the near future? Yeah.
This is Naveen. So the case studies you mentioned was little high level to understand.
Yeah.
Something very simple in layman terms. Can you explain, for example, for a human being to control his mind, a 5 minutes yoga for maybe 21 days will impact him in long run. Something I'm connecting to that. The, marketing as a science, you are bringing the science element.
Right.
But a small layman example which we can understand, which you have studied on that, which is done in Europe and US. Can you identify any small gap right now in Indian market, and is there something you have found that we can understand?
No, I think, see, conceptually, it's relevant everywhere. Like it's, Indian market is different because of the, the nature of how the consumers, probably how they behave or some of the tools that you're using. But ultimately, everybody is a human, right? So, conceptually, everywhere it is applicable. Statistics is a universal principle, right? And to give a very simple analogy, probably just think of it like, suppose you just, killed a mosquito at home, right? And the next moment the rain starts falling. Are you going to say that the rain started falling because you killed the mosquito?
Just like frog, they get married to.
Right.
Yeah.
Right. So that's causation and correlation. In fact, if you measure these things, suppose, and there is actually a very nice website. I forget the name. It's called Spurious Correlations. There are very famous spurious correlations. Like for instance, the number of dogs killed in road accidents to the number of. Again, I'm making this example up. To the number of days, rainfall occurred in some states in the United States. Do you really think there should be a connection between these two? No, but if you measure the correlation mathematically, it's proven, it's given by the famous statistician who did that work. You have a very high incidence of correlation. So that's the problem. But there's absolutely no element. From logic, we can say there's no causational element there. But the problem is in performance marketing, it's not so obvious all the time. Maybe Google ad spend went up and sales went up. Maybe the correlation is high, but maybe causation is not there.
Okay, thank you.
That's the point.
Okay, guys, we're going to take one more question. We are slightly running out of time. One question. There's one guy there.
Yes, please.
Hi. Yeah, thank you so much for the session. Very insightful. So just wanted to ask, this is of course a topic we should go in depth in and learn. So can you list like 5 influencers, including yourself, your YouTube channel name, and also maybe books, maybe top 3, something which we can look into to learn more about this in depth?
Sure. I mean, I think we can discuss personally also. Like there are, books and also there are plenty of, if you go to YouTube also, you will find lots of famous. Right now, you'll find mostly academicians talking about it more, but there are also people from the industry who are talking about how they're implementing incrementality tests. Feel free to please, talk to me personally about resources. That's very easy to share. Yeah. Any quick questions also, if you have.
Hi Kishule, I'm Akshaya, founder of New Hive Media. So I felt it was the last 30 minutes was so insightful and straight out of a Christopher Nolan movie. So 100% in a good way. So I just want to understand the way that you explained about causal impact and everything. So how can we implement all this for brands, and what tools or softwares or can we use to measure this for brands?
Yeah, no, I talked about the tech stack already. So, I mean, ready-made software, there are some third-party tools. I'm not going to name any tools here, but CustomerLabs is the place to go to. They will be, I'm sure, working on some of these things maybe in the future. But the third-party tools you can look up. There are some of them there. I'm not going to be an advocate of any of them, but these are open source solutions. These are publicly available in the public domain, right? So you can start getting a developer to implement them as well. Like that's a solution that's always going to be free.
Thank you. And another question is, can I know on brands on what basis they can use it? Like on what level of brands they can use? Like can a beginner brand who's just starting out, or in a mid-sized brand can use this? Or
yeah, mid-sized brands definitely. So suppose spending close to at least like 50 lakhs maybe. Again, I'm just giving a very sort of vague ballpark estimate, but very difficult to say exactly at what point, but certainly not new brands spending a few lakhs a month. That's not going to be very relevant for them.
got it. Thank you so much.
All right, guys. Thank you very much. I think we have a new title for Kish. It's Christopher Nolan. So, a couple of things. I have been trying to do this since 2011. This is where I started my career in terms of analytics. And obviously, this is all a lot of issues. The reason why we couldn't actually sort of implement with a lot of brands in India because nobody had data. So for anything, any of the statistics which Kish was talking about needs a lot of data. And if you're not collecting data, that's where the whole problem is going to be. So start collecting your data, 1P, the first party data, whether it is clicks, whether it is your CTRs or CPMs, whatever that is. So make sure you start collecting it and start collecting it today, because tomorrow, if you want to implement something and if you don't have data, you can't do anything. Okay, that is number one. Number two, again, always remember, attribution or any of the statistical methods is not to do an accuracy analysis. We are not doing an audit. What we are trying to understand is direction. Always think of these metrics is direction. Am I going in the right direction, right? Think of them like a lighthouse, not like a typical port. So you're going towards the lighthouse, not to the exact port. Okay. And as long as this is giving you direction towards 80-90%, be satisfied with it. Don't come and say my Shopify gets 100, my Meta shows 101. Where the hell is my 101? Okay. Or my Shopify shows 100, my GA4 says 95. Where is my another 5? That is not what you're trying to solve. So what you're trying to solve is direction. Are you going in the right direction? That's how you should start treating this. And you're not doing an audit or accounting firm where you will say, where is my 1 rupee? Where is my 2 rupees? That is not something you're trying to do. Okay. Always try to understand that with this. And finally, this is all slightly technical. I understand. And we wanted this to be part of this only to make you understand and realize the world is far ahead than what we are. Okay, we are still stuck at Facebook dashboard ROAS. What we ideally want to do is go ahead. And we are all here to support each other. You support with your knowledge, we support with our knowledge. Fish happy to support with this knowledge. So we all grow together as one large big family and team. Okay, so that's the reason why we want to have this. You may not understand today, but you will eventually reach that, because today you started learning about this, but one day, maybe 6 months later or 1 year later, you will start implementing one thing, and eventually you would be able to go. So don't lose motivation by after looking at Nolan's movie. You will understand after watching it third time or fourth time. Okay, thank you. Next to you guys.